Okay, let's study the basic grammar of template programming. Okay. If you want to program some functions which output one variable, like this one, like print integer, const integer, value b, it's going to work, right? And maybe you want this function like float. It's going to work because, well, the standard cout streaming has this streaming operation defined for this integer and float. Okay, this is going to work. And maybe we want to define something like this one, double. Okay, and maybe we also need to implement like this one, standard string v. Wow, so we need to include string. Oh, string. Okay, and some more maybe, right? So we have implemented multiple functions to print one variable. So we can use in this way: print integer 1, print float 2.123 maybe, print double 3, print string hello. What's wrong with print float? Yeah, there is a typo here, so it's not good for humans to program like this. It's very boring. Okay, so maybe you don't want this. Well, instead of print integer 1, print float 2 point something, print double something, print string something, it's very painful for programmers. So maybe you want something like this: print 1, print 2 point something, print for double number, print hello something, right? So this can be achieved by simply replacing your function names to this, like this. So they have different parameters. This is a print function, this is a print function. So four of them, the name of all four of the functions have the same name, but they have different parameters. So compiler can distinguish one of the function from others. They know what function to call by accepting this parameter. So this is integer, so compiler will use this function because the input is integer. And compiler will going to determine automatically to use this function, print this one, because the input parameter is float. So this is called function overloading. So maybe you can Google function overloading to confirm the name in C++. So you can have multiple definitions for the same function name in the same scope. The definition of the function must differ from each other by the types and or the number of arguments. Arguments means the parameters, the integer, float, double, string. Okay, so this feels better for programmers because they don't need to remember all the function names. They can simply type print the same one name. Okay, so it's good to use overloading, function overloading, to save your brain energy. But it also means, it still means that you need to implement all of them, right? Even if all of the streaming output operator is defined in standard library. So it's time to let your compiler generate codes for you. Okay? So the basic concept of template programming is, well, let your compiler generate codes for you automatically. Okay? So I'll show you an example. Type template here and T type. So you can use different name here like this. Oh, not semicolon. Well, something. But I like this. T, maybe type, input type, or parameter type, anything. And don't forget using class here, class or type name. But well, I like class. Okay, and define just one function, print const, and this is type name. This is the type you want to receive as a parameter v, like this, and implement this one. Okay, and just remove all the other implementations from your code. But you still want this one. You still want to print integer, float, double, string. But you have only one implementation here. You have only one function. But you want to this one. So let's execute it. It's working. You defined just only one function. So what happens inside is your compiler analyzes this part. So, well, the compiler says, wow, this function requires to be used with integer parameter, float parameter, double parameter, string parameter. And then your compiler compiles 4 versions of this function inside. You implemented only one function definition and body, right? You defined only one function, but your compiler generates 4 versions of this function inside automatically. So this is the basic concept of template programming.